Is my screen visible?
Yes.
Okay. Since today number of participants are very less, I will give a brief of what will be done next week. The intention is that now the students will start working using software. They will start applying the theoretical knowledge practically using software and see what happens. So in that context, let us look at for a short period of 10 minutes what we will be how we will be engaged from next session onwards. So the request to the participant students that please circulate this video. It's a very short, it would be short recording for 10 minutes only to everybody, and will give you a feel that what would be the next session onwards, how software will be there, how you can work along with it, and how you learn the theoretical knowledge in practical application. Okay. Well, you know that we are making attempts to prepare the students ready for industry, and our role is mentoring. Before proceeding further, we did discuss last time as well. Again, I'm emphasizing that we are somewhere near industry. We are in the industry 4.0 era, and it requires a different kind of experience, different kind of knowledge, skill. So our aim is to develop engineering undergrad students to be industry 4.0 ready. You guys are mechanical engineering students, and it has got always I say mechanical engineering is one of the branch you can divert into any kind of streams, many kind of streams. So today's session, it was planned, but we will defer the session on 22nd of May. I'll be briefing you what are the subjects we'll be covering. The aim is to develop an understanding how to build mathematical models on software platform, and then how do you use artificial intelligence logic, and then how do you predict future. So very interesting. Building mathematical model, you will be building mathematical model on software platform. Then you will see how your model is used to develop AI logic. AI logic, you won't be doing it. It will be done by software developers, but then they will be using your models. And then you will see that how your model is able to forecast, able to predict future problems, future defects, future failures. So this is a very interesting hands-on activity on software. Hope you will be enjoying. We had, since last March, we had been doing a lot of theoretical calculations, theoretical discussions we were doing. Bernoulli's, Euler's, affinity laws, we discussed a lot. We applied this for centrifugal pump. We discussed about the performance curve, head flow curve. This is the centrifugal pump, and this is the plant where it is being applied. Then we have to now learn how to apply the empirical formula. The formula which we have learned, these are the empirical formula. How to apply this empirical formula to develop mathematical models. So this will be, you will be doing how this empirical formula is used to develop mathematical models, And then machine learning techniques will be used to predict the failures. And we'll be using software. So students will be able to relate what is the objective then. Students will be able to relate industrial failure of centrifugal pump, with the fluid mechanics theoretical knowledge, what they have acquired. And it will continue for a number of sessions, starting with mathematical model and then actual application. Very briefly, a centrifugal, it is called a rule engine. And what we will be doing is that we will be developing library of rule engine. So this is a path forward for developing the rule engine for centrifugal pump library. The first is the empirical formula. For example, the power formula is flow times density times G times head divided by efficiency. So this is a formula you know. This is one of the empirical formulas. So you will be using many formulas. So we'll start with a simple one and then see how do we do it. And then we will be, second step will be the process input. We'll explain you how to do this process inputs. Then comes the mathematical formula. So where we are defining the limits after we make the model, and then we define the limits. We will explain one by one, and we'll explain all these things on software. And then logic is programmed. So this is not our domain, and this will be done by somebody else. And then rule engine is ready, and then the machine learning algorithm is deployed. And then you can see the prediction. How do we identify the future failures? For example, a simple pump is there. So we find out what is the power, and then we do find out the inputs. So inputs will be flow. So we have to measure flow. We have to get the density of that liquid. We have to calculate the head from the machine, and then we apply this formula. Now, this is the process. This is the process, and this is the curve. The last time we had been discussing, we will apply this curve in developing this model. Now, another example. This is another empirical formula. This is one empirical formula. Just now we talked, and this is the screen from the software, where these are the inputs. So we'll be working on this. These are the various inputs. So we were talking the process inputs. So we understood empirical formula. This is the process input. So on the left side, you can see the empirical formula, and on right side, this we will be inputting the data. What is the suction pressure? What is the discharge pressure? What is the flow? From here, whatever empirical formula requirements are there, we are filling the data. So these are called inputs. And at the end of the input, these are the next stage, that is mathematical model. So mathematical model is making a sense of whatever the formula is there, so that the machine can understand what we want to derive. So this is pretty tricky. We will be taking time to understand what is it, and then we will develop a simple mathematical model. So this is the last part, is the mathematical model. Though it is written only 2 lines, but a lot of thinking is here. And then once this is ready, then we will be applying the limits. The limits are called alarm and trigger. We'll be applying the limits. And then it is ready for handed over to the software engineers to do the coding and programming. And then it is ready to be launched on a practical purpose. The software access will be given from next session onwards. So you can work on the software. Initially, what we will be doing is that the software access will be given to the person who will be presenting the thing, and then we will be asking input from you guys, and then and he will be on your behalf putting the inputs, whatever requirements are there in the software. So once you understand the entire logic, it may take one session or two sessions. Then in selective basis, we will pick up a couple of students. We'll give user ID and password so they can go into the software and they can start working on the same basis. And we will follow the same principle. So this is how we will be able to achieve, say this is a cross section of the pump. It's the internal of the centrifugal pump, and this is a failure. So our aim is that before this failure takes place, our model should be able to tell and that this kind of failure is going to take place after 3 months or after 6 months. So that is the beauty. So you can understand that this is a very interesting feature. You know your theoretical details, theoretical fluid mechanics of this centrifugal pump. You apply this theoretical knowledge in developing a model, and then this model, with the help of machine learning algorithm, then you develop then you deploy it, and then it will start giving a prediction that this kind of failure will be there after maybe 1 month or maybe 1 year, or there is no danger of this and such kind of failure. The machine is running fine. So it gives a very strong uh, uh, feedback to the plant engineers, and uh, they can maintain this equipment. They can manage the machinery in much better way and very effectively. A lot of cost is saved, a lot of resources are saved, a lot of advantages are there. So this is the entire concept of you working on the software. So guys, we are requesting you that come in large numbers, try to understand. It's a very new technique. You will enjoy it because it's software based. You have to carry out a lot of things. And in that process, you will be learning a lot of things. These are all theory. Now, this theory will be seen as a, practically you will be doing this thing. We had been discussing since last 4 sessions on the theory. Now, how do you apply this theory? Each theory is quite complex, but then how these complex activities are being used in the practical field using the software. So guys, this is the intention of the session. And that's all from my side. I'm urging, please cascade this information to as many students as possible, and let us join on software, using the software. It would be very interesting, very interactive, and I hope the learning would be much enjoyable. And that's all from my side. Any question? I'm open. Raju, over to you.
Yes, any questions, students? Open the mic and you can talk. Any questions? At least write on the chat, no questions. If you cannot speak. Because that will help us to know that if we go proceed or we should wait for questions. Students? Difficult to put on the chat also. Okay, sir, I think we should proceed. This is how I look at it. Because
yeah, so let us end this session, Raju. This is a preparatory session for the next session. Let us circulate this video. This is a very short video to as many as possible. Have a discussion with Professor Gatke sir as well, so that next week onwards, we deploy our software.
Okay, fine.
That's
So,
all for today.
okay. Okay. Fine. Any questions? Anybody has anything to express? Any questions, please feel free so that we can attend it. If not, then we can close this session of today. Okay. Sir, I think there is no questions. So let's close this session. So maybe from next week, we can capture this software demonstration part, right? Or there is something that we will be putting some trainings to the students, right?
Sure.
Yeah. Okay, then. Thank you very much.
Thank you.
And we connect next week, 10:30 Saturday. Thank you.
Thank you, Amin.
Thank you, sir. Thank you.